Good day, grade 7.
I am your teacher, Marie.
Good day, grade 7. Now we're going to discuss a new topic. Let us enjoy watching while learning.
So, geometry comes from the Greek word geo means earth and metron means measure. It is the study of properties and relationship of points, line, angles, curve, surface, and solid. So it is also a mathematical system that is based on the undefined terms and proof statements such as postulate, assumptions, and theorems. So to begin our study in geometry, we will first look into its basic concept and terms. So what are the undefined terms in geometry? So we're going to discuss first is the basic concept in geometry. So undefined terms in geometry. First is point. It has length, width, or thickness. It has no dimension. It cannot be seen or touched, but has position or location. Real-world objects such as a tip of pen or mole in human body suggest point. A dot is usually used to represent a point. It is named using capital letter, so we have point A and point D. Line. In geometry, it always means a straight line that extends indefinitely into opposite direction. It is a set of points extending infinitely on each opposite direction. It is one-dimensional because it has length only. It has no width or no thickness. It can be named using two distinct points on it or by a lowercase letter. So here we have line AB or line BA. Plane. It is a flat surface that extends infinitely in all directions. It is two-dimensional because it has length and width. It has no height. It is represented by four-sided figures such as parallelogram. It can be named using a capital letter placed on its corner by 3 points, not on the line but on the plane, or by a Greek letter. So we have here the plane ABC or plane P or plane beta. Important concept in geometry will be defined using this term. It will be used together along with the ordinary word as basic to define the other geometric terms. Space, for example, is a collection of all points. The following is characteristic using be observed in defining a term to have a good definition. Number 1, it should contain ordinary words and geometric terms that have been previously defined or accepted undefined. Number 2, it should list only the essential properties of the term being defined. Number 3, it should be reversible. To understand further the relationship between and among points, line, planes, and the terms postulate, theorems, and corollary will be defined. Number 1, postulate. This is a statement which is accepted as true without proof. It can be used as reason in proving some mathematical statement. Theorem. It is a statement that is need to be proven. Once proven, it can also be used as reason in proving other statement. Corollary is a direct consequence of another theorem. Now, the following are some of the postulate and theorem that can be helped describe the relationship among points, line, planes, and other will be represented on succeeding discussion. So first postulate is line postulate. 2 points directed exactly one line. Postulate 2. 3 collinear points are contained in at least one plane and 3 non-collinear points are contained in exactly one plane. Postulate 3. If 2 distinct planes intersect, then their intersection is a line. Postulate 4. If 2 points of a line are in the plane, then the line is in the plane. Now we have the theorems. Theorem 1. 2 distinct lines intersect at one point. Theorem 2. If a line not contained in a plane intersect the plane, then the intersection contains only one point. Theorem 3, exactly one plane contains a given line and a point not on the line. Theorem 4, exactly one plane contains two intersecting lines. Subset of a line. A line is an infinite set of points. In line L, the part from point A to point B is called a segment. Definition of a segment: segment AB denoted by the overhead line AB or overhead line BA is the union of points. A, B, and all points between them, A and B, are called the endpoint of a segment. A segment is a subset of a line. The length of the segment is the distance between its endpoint. In the line L, the length of the segment AB is the distance between A and B, denoted by AB. Let P be the point between point A and point B in the line L. So, in the figures, we have AP plus PB is equal to AB. So, this will be the definition of betweenness. Point P is said to be between A and B if and only if A, P, and B are distinct points of the same line and AP plus PB is equal to AB. The rule postulates there is one-to-one corresponding between the point of the line and the set of real numbers such that the distance between the 2 points of the line is absolutely value of the difference between the corresponding parts on the line or corresponding side. Now we have here the congruent segment. On the number line, we have AB is equal to the absolute value of 5 minus the quantity of negative 3, then it is equal to 8. And CD is equal to the absolute value of 15 minus 7, then it is equal to 8. The length of the segment is the positive distance between the endpoints. From this, it can be concluded that segment AB and CD are equal. And since they have the same length, they are said to be congruent segments. Definition of congruent segments. There is a one-to-one corresponding between the point of the line and the set of real numbers such that the distance between any two absolute value of difference between corresponding number. Now we have the midpoint of the segment. If in line L, the distance of P from A is 6 and the distance of P from B is also 6. So if point P lies between A and B and point P is equidistant from A and B, then point P is midpoint of segment AB. And here is the definition for the midpoint of a segment. P is the midpoint of segment AB if and only if P lie between A and B and AP is equal to BP or PB. Now we have here the definition of collinear points and coplanar points. Points are collinear if they are on the same line. Points are coplanar if they are on the same plane. Ray. Ray is a subset of the line that starts at one point of a line that goes on indefinitely in one direction. Ray AC is denoted by this symbol. We have the AB with overhead arrow line. Start from point A and goes indefinitely to the right of B. The point A is also called the endpoint of ray AB. Definition of a ray. Ray AB is the union of ray AB and all points C such that P is between A and B. On the next figure, below we have the ray YX and ray YZ are opposite ray. So this will be the figures, and therefore we have ray YX and ray YZ are opposite ray if and only they are subset of the same line and have a common endpoint. The common endpoint of ray YX and ray YZ is the point Y. In that, we form a theorem. So given, we have theorem 5, given the ray AB, there is exactly one point P that lie at the distance x from A. Theorem 6, every segment has exactly one midpoint. Now we have the angles. Definition of an angle. An angle is the union of two non-collinear rays with a common endpoints. Below are example of angles where there are not two non-collinear rays that shares a common endpoints. Their common endpoint is called the vertex of the angles, and the two rays are called the side of the angle. The symbol for an angle is this. In the figure below, it can be named using the points on the angle with the vertex on the middle. The angle can be named as angle ABC, angle CBA, angle B, or angle 1. An angle is a plane segment in it into three sets of points, which are the points in the interior of the angle, the points on the exterior of the angles, and the points on the angle itself, like in the figures that we have. In the figures, point M is the interior of angle ABC. The point K is the exterior of the angle, and point L is the point on the angles. Angles are measured in degrees. In symbol is this. Approximate measure of angle can be determined by using the protractor in measuring the angle using the protractor. It can be done by putting it in the center on the vertex of the angles. So this is an example of a protractor that we have. So in the figures, angle ABC is equal to 50 degrees. It can be written as angle ABC is equal to 50 degrees, or the measure of angle ABC is equal to 50. Now we have the postulate 7 about the measure angle postulate. To every angle, there is corresponding a unique real number, or R, where R is greater than 0 and R is less than 180. In the figure 16.12, angle ABP and angle CBP are coplanar angles with a common vertex P and a common side BP, or ray BP. So here we have the postulate angle addition of postulate. So P, if P is the interior of angle ABC, then the measure of angle ABC is equal to the measure of angle ABP plus the measure of angle CBP. By the postulate 9, or the angle addition postulate, from this postulate, we have the angle addition postulate. The measure of angle ABC is equal to the measure of angle ABP plus the measure of angle CBP. Therefore, the measure of angle ABC is equal to 40 plus 30. And 40 plus 30 is equal to 70. And we can conclude that the measure of angle ABC is equal to 70. In the next figure, the two given angles have been the same measure. So this will be the definition of congruent angles. Two angles are congruent if and only if their measure are equals. In symbol, we have angle X is congruent to angle Y if and only if the measure of angle X is equal to the measure of angle Y. Since the measure of angle X is equal to the measure of angle Y, by the definition of congruent angle, angle X and angle Y are congruent. In the symbol, that is congruent. In this symbol, we can read it as is congruent to. It can be written as angle X is congruent to angle Y. We have here the bisector of the angle. So in the figure 16.14, the measure of angle XYV and the measure of angle ZYV are equal. And the ray VY is the bisector of angle XYZ. So here is the definition of angle bisector. The ray VY is the bisector of angle XYZ if and only if V is the interior of angle XYZ and angle XYV, congruent to angle ZYV. So ray VY that lie on the interior of the angle bisector, angle XYZ into two congruent angles.
Thank you. Enjoy watching while learning. This is your teacher, Miss Marimar F. Figalan.